We are continuing in our broad theme about causation, and we are looking more carefully at how scientists generally investigate causes, and that is through controlled experiments. So there are three types that we're going to consider in this video. One is the randomized experimental studies. The experimental studies that are randomized have an experimental group and a control group. And these are randomly chosen from the general population. A classic example of this kind of experiment would be those that use lab rats. So when one group of the rats is exposed to something, for example, a drug or a vitamin or something in a diet such as saccharin or radon or any number of things, and another group is not exposed to that thing, or possibly exposed to varying degrees, so you might have multiple groups exposed to various degrees. These are randomized experimental studies, and these are very common and useful. An example of a randomized experimental study would include the lab rat case, and so we'll look at more carefully at one of these in detail. And what we do is, after we find the suspected causal effects, then we generalize those to a broader population. So broadly speaking, these involve inductive generalization. So consider this example. 200 mice, you split them into two groups of 100, and one group is given an experimental drug. Say we follow this and 50 of that group gets cancer, in the other group only one got cancer, and you certainly could conclude that the experimental drug causes cancer, and that study's going to end the development of that drug. Now, the generalization, of course, is that all rats would have similar responses at the same rates. If 50% of the experimental rats who ingested a drug developed stomach cancer, say, then 50% of all rats would also develop stomach cancer, and that's why it's an inductive generalization. Now, typically, we're not that concerned about cancer in rats, so these usually involve arguments by analogy. What we're more interested in is what might cause cancer in a human. So we have to do an analogy that humans, and assume humans would have similar responses as the rats did. Strengths of the randomized experimental studies include, it allows for a significant amount of control over the experiment. This allows you to set up the parameters to make sure the control group has everything else the same. And so this is very helpful for isolating a suspected cause or constructing an experiment to see what effects might come from the cause in question. And these are relatively easy to carry out. At least the reasoning process is very clear. You can carry these out in the physical sciences as well. So for example, determining characteristic of metals. So with a very high degree of certainty, you can determine the thickness of copper wire required to carry a certain voltage and a certain amperage of electricity, and you can set up the experiment and do this with great certainty in the physical sciences. Now, there are some weaknesses of randomized experimental studies, and the main weakness that we'll be concerned about are the numerous ethical and legal issues that restrict the type of study on humans. So it would be better if we could just, more useful for science, that is, if we could just give a control group of humans and an experimental group of humans and give the experimental group the drug and find out what happens. Of course, that would give us much better information on what the drug might do on humans, but you have those legal and ethical concerns, and human health concerns are often investigated initially then with studies involving animals. Lab rats are especially useful. They're relatively inexpensive to have and to keep in the lab, and they do have enough similarities to humans to draw some conclusions. Now, obviously, an argument from analogy has to be made. And so in turn, that analogy reduces the strength of the argument because obviously there are significant differences between rats and humans. The second type of controlled experiment to consider are prospective studies. Prospective studies are forward-looking. So here the experimental group is not manipulated, but already has a characteristic thought to be causally relevant. So for example, we want to look at mothers who smoke during pregnancy. So they've already done this, say, or they're already doing this. We're not manipulating anything, but we're following those who are doing it, and then you have the control group who are not. So these are people who are voluntarily engaging in an activity that is thought to be relevant to the effect under investigation. So maybe it's ADHD if you're considering what happens when women smoke during pregnancy or something like that. The control group then is going to be selected that matches the experimental group in all the features relevant to the effect, except for the causal factor under consideration. So you want again, the same ages, race, socioeconomic status, all of those things you want to keep the same, except for the causal effect under consideration. And the experimenter simply observes what happens in the two groups and then analyzes the data. So there is no manipulation, it's just people living their lives as they normally would. The advantage here is that you could do this on humans without that ethical and legal concern that we mentioned with randomized experimental studies. An example of this, a different one other than smoking during pregnancy, maybe probably more positive one, studies on eating a vegetarian diet you can conduct in this way. So you don't force people to become vegetarians, you just identify those who already are. And vegetarians might be monitored for percent body fat, muscle density, rate of heart disease. And of course, you're comparing that to a control group that are similar, and you draw the conclusions of what will happen if you have a vegetarian diet. Now, a weakness of prospective studies is that it takes a long time to carry out these experiments and gather the data. And it's often very expensive because of that. The longer the time, the more expense in the process. A third type of controlled experiment is that of a retrospective study. And these are, as the name implies, backward looking. Here, the experimental group is chosen from a population that already exhibits the suspected effect. So the effect in question is already there in your experimental group. And then you select a control group, again, similar to the experimental group in all the relevant ways, except that they are lacking the effect under investigation. And then the experimenters examine the histories of the two groups to try to figure out what differences there are that may have caused the effect that you are investigating. So they investigate to see if a causal claim might be justified, and this would be a good way of studying diseases. For example, a study of those with cervical cancers. You identify a group of women who have cervical cancer, that's the experimental group, and then you identify those who do not, that are matching in the relevant characteristics other than that they don't have cervical cancer, and you do a history of those two groups, trying to figure out what differences there might be. Now, a weakness of this kind of group, this kind of study rather, is that some participants might find the required questionnaires intrusive and an invasion of privacy. We're very concerned about privacy these days, and so some may be hesitant in giving honest responses. For example, the retrospective investigation of cervical cancer, the ones that have been done, would include questions about one's past sexual activity, for example, past sexually transmitted diseases, and so on. And so participants may be a little hesitant at giving that information, but that could be relevant to whether or not cervical cancer is present. Now, for all three of the types of controlled experiments that we've considered, there are criteria to evaluate them. Some of these apply more closely to the randomized studies than the other group, but we've mentioned control groups and experimental groups in all three of these, and so the degree of similarity between those two groups is going to be very relevant for evaluating the controlled experiment. How well did you do at matching the characteristics under question, under investigation, and how well did you do this process? That's going to play a role in how well the experiment determines a cause. Second, the degree to which the groups are representative of the general population. So you want to do this with groups that represent the broad population as a whole. Third, the degree to which the experiment accounts for psychological factors that might be present when you're conducting the study, such as is done in double-blind experiments, and we'll put that on hold for a moment and explain that in the next slide. And then fourth, the criterion of if the study requires arguments from analogies, the degree to which these meet the criteria for analogous arguments. So that is, are the similarities in question relevant to the issue? Are there sufficient number of similarities? Those things help determine how good your argument from analogy is. So obviously, if you're doing studies on lab rats and drawing conclusions about humans, you're going to want to know those things of the similarities between humans and lab rats and whether those are relevant to the issue at hand. Of course, they need to be for the controlled experiment to be a successful one. Now, let's talk about what we mean with blind experiments and double-blind experiments. A blind experiment is when the participating subjects do not know if they are being subjected to the suspected cause or not. So these, when you get to the human trial phase of drugs, for example, you want to set it up so that the people receiving the experimental drug and the people in the control group who are not receiving the experimental drug, neither group knows which group they're in. An individual would never know what group they're in. That's a blind experiment. So for example, we use placebos in this case. These are common in drug experiments. Now, there have been some ethical concerns raised about the use of placebos themselves. It certainly involves some kind of deception at hand. And it's also possible that some study shows that there's a medication that is extremely successful. And so you want to stop that so that those who are getting the placebos can get the actual drug because it's known to be successful very quickly. Now, a double-blind experiment is when both the subjects, the participants, and the experimenters, the people conducting the experiment, are ignorant of who's receiving a placebo and who is not, right? Who's in the control group and who's in the experimental group. So in these cases, a third party would then keep track of who's who by using coded numbers, and those conducting the experiment then won't be swayed in any way in how they're evaluating the results. Those are controlled experiments. We have much more to say about causation in future videos.